Hello and a warm welcome to the next lecture. In this lecture, let us focus on few of the other theoretical concepts which are related to computational fluid dynamics. I'm trying to build up your foundation. Maybe you are really aware of this concept, or maybe you are not aware of this. Nevertheless, let us enlighten ourselves. First of all, what is fluid dynamics? Fluid dynamics is nothing but a study of the physics of a fluid, especially when the fluid is in motion. The fluid can be regarded as a liquid, it can be regarded as air as well. And since we have plenty of applications surrounding us with respect to fluids, for example, the way we are breathing, this is something related to fluid dynamics. The way we are using water in the taps, that is associated with fluid dynamics again. You are moving to your university, or you're moving to your office, workplace, you're moving in a vehicle, maybe cycle, bicycle, or a motorbike, or a car. All of these vehicles interact with the air, so there again comes fluid dynamics in picture. You travel to different countries with the help of air transport, fluid dynamic comes into picture. We are basically trying to send satellites into the atmosphere with the help of satellite launch vehicles. We again have fluid dynamics into the picture. The propulsion of rocket engine is nothing but the utilization of certain gases, certain fuel or propellant, to burn them, to exhaust them from the nozzle. That is again a kind of fluid dynamic study. So each and every aspect which are surrounding us is most of them are directly or indirectly related to fluid dynamics. For this purpose, it has been an interest for different researchers across the world since earlier times. And most of the researchers in the previous generations utilized experimental approach and theoretical approach for their investigations or research. But in recent times, due to the development of computational resources, or due to the presence of high demanding computers with ourselves, we are now able to perform this fluid dynamic study with the help of computers in the software on our computer. Now, what is fluid dynamic, or what is computational fluid dynamic to be precise? It is nothing but the utilization of computational resources for performing an investigation. For example, if you are utilizing an experimental apparatus, then that particular research is based on experimental studies. Similarly, if you are utilizing a numerical solver, then your research is based on numerical study, or nothing but the computational approach. So these are the three different approaches which are vividly used, and in recent times we are more focusing on the numerical approach, that is nothing but the computational approach. Let us move forward. So what are CFD results analogous to? Especially if we talk with respect to the aerospace point of view or aerodynamic point of view, the CFD results are similar or identical to the wind tunnel results. You have this wind tunnel on the right hand side, and there is a test specimen being placed over here. This is a scaled model of an aircraft which is being fixed on a fixed support. The air is being passed on the aircraft, and there are sensors being present on the aircraft which measure the pressure variations on the surface of the aircraft. That is the scale model of the aircraft. So the results what we are getting in wind tunnel, we are able to achieve those results with the help of computers as well. That is the reason I mentioned a point over here, that is CFD results are analogous to wind tunnel results. They both represent set of data for given flow configurations at different Mach number, Reynolds numbers, temperatures, etc. Now the scenario being depicted or being created in the wind tunnel, for example, if you want to measure the velocity and the variations of pressure on this scale model at a velocity of 30 meters per second, you just have to ensure that your wind tunnel air is at 30 meters per second. If you want to increase the speed of air, say for example you want to move it 200 meters per second, then you just have to change the settings or the options what we have in your wind tunnel. provided your wind tunnel must be created in order to replicate those kind of flows what you actually want. Now, the same configuration options or the same flow field configuration options can be varied in the CFD software as well. So CFD is basically analogous to the wind tunnel, but the difference between them is wind tunnel is a big device. It occupies rooms of space. It requires a large size. It requires big fans which are pumping in air at higher speeds. So all these comes under the category of experimental approach basically. So what is the biggest limitation? First of all, the limitation is with respect to the size. Secondly, the limitation is with respect to the size of this model what we are considering for our research. Now you can see this is an aircraft model, but this model does not replicate the actual aircraft size. It has been scaled down because the wind tunnel what we had over here has certain dimensions. Okay, it has some limits. We cannot pump in or we cannot pull in a huge Airbus aircraft in this wind tunnel. It is next to impossible. Therefore, we are utilizing a computer program, a solver, a software, what you can say in simple terms, which is performing the same task digitally. That is the reason we have the CFD software, and that is the main purpose of CFD software to solve the flow motion or the fluid flow either on the external surface or on the internal surfaces. And for that reason, we can also call the CFD software as a transportable wind tunnel, because we can carry the software in our laptops, in the computers, and we can just move it. We can move the laptop from one place to another place. So it is a kind of, we are just carrying a digital wind tunnel in our laptops with ourselves. Let us move forward. So we have this few images which I have obviously downloaded from internet. These are nothing but representing the experimental study of different scale models. I was really not sure about this bird, but it was looking really fascinating for me to pull in. So I just try to import this image over here. So we have the scale model of a passenger aircraft, then we have an automobile over here, and we have a burger over here, and this is a bird. So these images are depicting the experimental study in a wind tunnel. Now, what is a computer program? A computer program is nothing but a tool with which we can carry out experiments. And the experiments that we carry out in the wind tunnel, the similar experiments can now be carried out in the computer program. The experiments performed with computer program are named as numerical experiments. So that is the reason I was just referring numerical since in the beginning slides. So this is the purpose I'm referring the computer software simulations as numerical experiments. We are performing an experiment in the software. The experiment which we have to perform physically, we are now performing it computationally. In order to perform the experiment computationally, we have to build up a model. We have to develop the same conditions which can allow us to replicate similar flow that a real body can face. So that is the reason we are just referring it as numerical experiments. You can remember this thing. Let us move to the next slide. Now, we have plenty of applications of CFD, but CFD can also be used as a design tool. Now you can see how this particular aircraft, the aircraft belonging to a very, a very olden time, I can say maybe, 40, 50 years old. And you can see the design of this aircraft. In parallel to this, you can also see the automobiles which existed in the olden times, right? So if you are observing the designs are quite basic. They are not aerodynamic. And we have basically utilized the CFD and we have transformed these automobiles into this level. And you can see the sleek design over here. Now, of course, you will not be having a passenger car in this particular shape because this will be pretty costly for us to purchase. But you also have the recent passenger cars, more aerodynamic in comparison with the olden cars which were available for the common public. Analogous to this, you can also see the aircraft differences. You can see this aircraft, which is nothing but for F-16 aircraft. It is nothing but a scale model of the F-16 aircraft developed in the CAD model. And for your information, I have created this design in a designing software named as Creo Parametric. Now you can see the difference between them. We have utilized the CFD and we have optimized the design. We have made it more aerodynamic, more optimized, and with higher performance as well. So the difference is not only with respect to the beautiful design, but it is also with respect to the efficiency what we are able to attain with the help of CFD. Therefore, CFD is a very powerful tool. Apart from that, there are other applications as well. We have the flow in the piston. We have the urban areas where we can analyze the flow movement of air around the buildings. Then we have this internal compressors and turbines of engines and gas turbines. Then we have the simulation of underwater bodies such as submarines. We can perform all these things in the CFD software. We also have this internal flows in electrical cabinet assemblies, right? And we also have a room ventilation, indoor ventilation. We can analyze how our air conditioner is pumping in the air and what kind of air movement is existing in the room. We can also analyze the transportation of contaminants being emitted from a sick passenger in the room. We can perform all those activities and we can investigate all those factors in a CFD software. So these are the different applications. I just thought to brief up about it. Now let us move to the next video.